Hello everyone, Science Spot is a podcast that shines a spotlight on the latest scientific technology from Japan. Your host is Ren from SCIEN-TALK. Today I'm gonna talk about the cooling things with sound, known as acoustic cooling. Do you know what typically powers the cooling devices we use every day, like refrigerators and air conditioners? Most commonly, they use a method called vapor compression, which relies on the refrigerant, like from gas. However, some of these refrigerants are greenhouse gases that contribute to global warming, raising concerns about their environmental impact. This topic is I talked the previous episodes. But a new and environmentally friendly cooling technology that gains significant attention is what we're discussing today, acoustic cooling. As the name suggests, this is technology that uses sound waves to move heat, literally cooling with sound. So how exactly does it cool? Imagine pumping air into a bicycle tire very quickly. The nozzle often feels warm. That's because compressing air generates heat. Conversely, if you quickly release air from a tire, it feels cold because the expanding air absorbs heat. Acoustic cooling works on this very same principle. When sound waves, for instance, move through a gas like air or an insert gas, they cause the gas to rapidly expand and compress. During this process, the gas absorbs and releases heat from its surroundings, a phenomenon called adiabatic expansion and compression. Specifically, when this gas passes through a porous material called a stack, and efficient heat exchange occurs between the gas and the solid walls. This causes the heat to move in one direction, creating a cooling effect. This entire process is highly efficient, described as the reversible cycle with high energy conversion efficacy. And the advantages of acoustic cooling is environmentally friendly. A major advantage is that it doesn't use refrigerant like CFCs, which contributes to global warming, making it environmentally friendly. And easy maintenance. With fewer moving parts, it's less prone to breakdowns and are relatively easy to maintain. And quiet operation. It operates much more quietly compared to traditional compressor-based cooling system. This acoustic cooling technology has made remarkable progress in recent years, particularly with the traveling wave type. Efficiencies that defy conventional wisdom have been reported. In Japan, efforts to commercialize this technology are well underway. And the Chuo Seiki Corporation and the Tokai University have jointly developed a thermoacoustic cooling system that utilized waste heat from factories, and they have successfully implemented it on a production line for the first time in Japan. This system can operate using factory waste heat at 250 degrees Celsius and generates cooling down to minus 30 degrees Celsius. This is a truly groundbreaking step because it effectively utilizes previously wasted industrial heat and contributes to reducing carbon dioxide emissions. The research team aims to apply this technology to a wider range of fields. Beyond general factory cooling and freezers, the possibilities are vast, from power to generation and cooling using waste heat from ship engines to home generators, air conditioning, and refrigerators powered by solar heat. Especially promising its application in the car air conditioning system using engine waste heat, which is expected to significantly improve fuel efficiency and reduce environmental impact. Furthermore, thanks to its characteristics of low vibration, long lifespan, and maintenance-free operation, acoustic cooling is also gathering attention as a cryocooling technology in military or space applications. So as we have seen, acoustic cooling is an incredibly environmentally friendly technology because it can cool using only air without the need for foam or other refrigerants. Of course, there are still challenges for commercialization, such as further improving power consumption efficiency and addressing noise issues inherent in using sounds. But advancement like optimizing the stack and the resonance tube designs and the evolution of cutting-edge noise reduction technology like active noise control systems are helping to overcome these hurdles. While acoustic cooling still has some technologically immature aspects, its low environmental impact and the potential to utilize untapped waste heat make it a highly anticipated future cooling technology that can contribute to achieving a sustainable society. So that's all for today's Science Spot. Today, let me chat a bit this time. Now I'm planning a driving trip to Cornwall in the UK soon, so I'm recording this series on refrigerators at once or twice. My apologies if the audio isn't great. But I hear Cornwall has beautiful resort-like scenery, so I'm hoping to film some videos and share my thoughts about it later. So that's all today's Science Spot. This podcast is broadcast daily on weekday morning in both Japanese and English. I'd love for you to listen to the podcast and post your notes and thoughts with #ScienceSpot. See you next time.